All right, guys, one more day of sequences and series. Today we're going to do what's called recursive rules for sequences and functions. Okay, here's what recursive is. A big deal. Like, what does it even mean? Recursive basically gives the beginning terms. It's going to tell you where to start the series. It's going to tell you what the beginning terms of a sequence are. Then give you an equation. It's called a recursive equation. It tells you how the next term is related to the ones before it. So basically, the terms in the sequence are based on the ones that come before them. You have to know the ones before them to get the next term. The next term is based on the previous term. All right, for example, this one says write the first 6 terms of the sequence. Okay, this is a big important slide, so stay with me here if you can. But this is saying there, the 0, I know it's kind of weird, we haven't seen much of that, but the 0 term is 1. When you see this symbol, remember this means the next term or the last term. This is saying the next term is the previous term, because it says n minus 1. Anytime you see a n minus 1, that's talking about the previous term. In this case, the 0 term, plus 4. So 2 ways you can do this. One is, since you're looking for the first term, you can plug a 1 in everywhere you see an n, like that. Trying to there. There we go. And what that says then is that would be like a1 equals a0, the 0 term, plus 4. Well, the 0 term was 1, so it's really 1 plus 4, which is 5. A2, just reading this, remember, it's saying this. The next term is the previous term plus 4. So A2 would be the previous term plus 4, or 9. The next term would be the previous term plus 4, which is 13. The fourth term would be the previous term plus 4, 17. And the fifth term would be the previous term plus 4, which is 21. I know I said find the first 6 terms. Technically, the 0 term is the first one, so there's 2, 3, 4, 5, 6 terms. All right, let's look at another one. Hope that made a little bit of sense. Listen to this one very carefully if that didn't. This time says the first term is 1. All right, now, what this is saying is the next term is 3 times the previous term. 3 times the previous term. So the second term is going to be 3 times the one right before it, which is 1. 3 times 1 is 3. The third term will be 3 times the previous term. 3 times the second term will be 9. The fourth term would be 3 times the previous term, or 3 times 9, which is 27. The fifth term will be 3 times the previous term, which was 27. 3 times 27 is 81. And lastly, the sixth term will be 3 times the previous term, that's what that says, which is 243, 3 times 81. All right, so the way you write a sequence recursively for an arithmetic or geometric is, if it's an arithmetic one, we're going to write it just by doing the previous term plus whatever d is, plus what you're adding. If it's geometric, we're going to take the previous term and multiply it times r, whatever your common ratio is, like we did in geometric sequences. Okay, let me show you a couple of these. Okay, the first one here says write a recursive rule. Remember, rule means leave the n in of the sequence. So here, that's arithmetic. It's going up by 10, up by 10, up by 10. So I'm going to say, I shouldn't have started there. Always tell what the first term is. We're starting with 3. And I'm going to say the next term is the previous term. Remember, let's say right, previous term, plus 10, because that's D, and it's arithmetic. So that's all you need to do there. That's how you write the recursive rule for an arithmetic. Now, if it's geometric, like this one, I think that's geometric, 40 over 16. Yes, they're definitely multiplying there. R is 2.5, so that's geometric. Again, to what the first term is, it's 16. And then I'm going here. The next term is the first term times r, 2.5. So I'm going to say it's 2.5 times the previous term. That's how you find the next term. That's the recursive rule for geometric. Here's the recursive rule for arithmetic. Hopefully not too bad there. One more slide. Okay, this is one. It says write recursive for the sequence, and it's not arithmetic or geometric. That's the kind where you just got to play with it and see what the pattern is. I think I see what the pattern is. It's going like this. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. So you're adding the 2 previous terms to get the next term. I hope you caught what I just said. You're adding the 2 previous terms to get the next term. So I'm going to say this. The first term is 1. This is a weird case. I'm going to go ahead and see what the second term is too. The second term is also 2. All right, so now I'm going to write my recursive. The next term would be the previous term plus the term that is 2 back from what you're looking for. So if I'm looking for the third term, I'm going to add the second term and the first term. If I'm looking for the fourth term, I'm going to add the third term plus the second term. Okay, so that's why I went ahead and wrote 2 numbers out here, 2 terms, and then wrote my sequence like that. Okay, so they'll give you a couple tomorrow where you got to kind of do that and kind of figure out what's going on and what kind of rule you need to write, and it'll be fun, and we'll play with it and figure it out. All right, so I'll see you tomorrow, and we'll work on it like we always do. See you, bye.